Hello everyone and welcome back to the channel. Before we begin here today, please make sure that you like and subscribe because it really does help out our channel and it also really helps us reach others in need of assistance with these topics. So what we're going to be discussing today is trigonometry, and we're going to be calculating the actual angle values in right triangles for the three triangles shown on the screen here. We did a previous two-part series where we calculated what these angles would be in relevance to cosine, sine, and tangent. For this particular one, we're going to be using sine, cosine, or tangent trig functions and their inverse functions to find the angle value, and we just have to use one of the three, and we're going to be using the one that is the easiest to find for each of these triangles. So just a quick reminder before we get going here that when using sine, cosine, and tangent, it is always nice to remember the acronym of SOH-CAH-TOA, which will tell you that the sine is the opposite over the hypotenuse, the cosine is the adjacent over the hypotenuse, and the tangent is the opposite over the adjacent. So what we're going to do is we're going to look at each individual triangle and we're going to solve for the angle shown there as theta for each triangle using one of these trig functions. So looking at our first one right here, this would be our second and this will be our third. So looking at our first one, our angle is in this corner. So we have a 15 on this side and an 8 on this side. The hypotenuse is unknown at this time. So instead of trying to find the hypotenuse, which we could, we're going to save some time here and we're going to use the trig function that does not involve a hypotenuse, which is the tangent of opposite over adjacent. Now, we just have to determine what's the opposite and what's the adjacent here. Well, the adjacent is the shorter side of the triangle that is attached to the angle or where the angle is being measured from. So this would be my adjacent. And the opposite side is the shorter leg or the other leg that the angle is not touching, that is opposite the angle on the other side of the triangle. So with this one, we have tangent of theta is equal to our opposite, which is 8, over our adjacent, which is 15. So we would have tangent theta is equal to 8 over 15 in decimal form is 0.533. And then utilizing our inverse function of tangent inverse of 0.533, that would give us an angle of 28.07 degrees. Keep in mind a few things here. If you plugged in this equation right here of tangent inverse of 0.533 and you got a different number other than 28.07, your calculator might be in radians, so you want to switch that over to degrees. Typically with calculators, there is a mode function where you can switch from radians to degrees. One other thing, keep in mind, when we write tangent inverse like this, it is not saying that it is 1 over the tangent of the angle. That is incorrect. This is a totally different type of function, which we did explain that in previous videos if you want to check that out. So there's our first one. So our second triangle here, which let's just change colors. So with our second triangle, we know the hypotenuse side, and we know the opposite side. The adjacent side is unknown at this time. Keep in mind that the opposite side is opposite the angle. It's not touching the angle. So whenever you have the opposite and you have the hypotenuse, it would be much easier to use sine. That way we don't have to find the adjacent side at all. So the sine of our angle is equal to our opposite over our hypotenuse, which in this case would be the square root of 5 over the square root of 10. So the sine of our angle, square root of 5 over the square root of 10 in decimal form, is 0.707. So theta equals the sine inverse of 0.707. So that gives me an angle for theta of exactly 45 degrees. So nothing super tricky here, just realizing what would be the fastest trig function to use. And you can use all three trig functions with each of these triangles. We're just showing you the faster way to do it, utilizing one of the trig functions with the given sides. All right, on to triangle number 3. Let's switch colors again. So with triangle number 3, we know the hypotenuse. And let's see here, we also know the opposite. So once again, we don't know anything about the adjacent side over here. So we have to determine what that angle is, once again, using sine. So sine of theta is equal to our opposite of 4 over 6, which 4 divided by 6 gives us 0.75. So our sine inverse of 4 divided by 6, which actually, hang on, 4 divided by 6 is not 3/4, it is 2/3. Sorry about that. So that'd be 6.67. So sine inverse of that would give us, let me write it out real quick. So sine inverse of 0.667. So then our theta angle would be 41.81 degrees. So with this particular problem, we did not use cosine at all. It did not pop up that we would have a triangle that had the adjacent with the hypotenuse known. The first one was adjacent, opposite. Second one, opposite, hypotenuse. And the third one, opposite, hypotenuse. So cosine would only be utilized if we knew the adjacent over the hypotenuse, which, as I said earlier, you could utilize that with any of these triangles. You just have to find the missing side for each one. So this was walking you through how to quickly find that angle just using one of the trig functions out of the 3 instead of all of them, which you could find all of them if you wanted to. It's just much faster just to use the one with the given information. So I hope this video was helpful. And if you want to see more videos or more problem solved this Friday, please check out the other videos on our channel. As I said, we have previous trigonometry videos going over the angles of sine, cosine, and tangent. Also, if you haven't done so already, please like this video, leave a positive comment below, and please subscribe to the channel because it really does help us out. Thank you for watching, and I hope you have a fantastic day.